Hi students, welcome to today's class. Today I am going to explain a very important concept, that is family of straight lines. So this is also very important for your JEE MAINS 2023 examinations, which was going to commence from January and April. Okay, I hope that you are all preparing well for your examinations. So in these videos I explaining the various concepts from the chapter straight line. So each and every concept I am explaining in detailed. Once the concepts are over, now I will switch on to the problematic part. Okay, so let us start the our class. So here, family of straight lines. The name itself suggesting family. Family means what? So if in a family we have mother, father, a son and a daughter will be there. So then we call it as a family. So here also, family of straight lines means what? So a group of lines which is satisfying a certain property. So for example, see here there are some lines are there like this. So these are the lines. So this is a line, this is a line, this. So this is also, this is a one set of lines. Okay. Let us take the another set as so this is another set of lines. So this is another set of lines. Okay, now let us take another set. So this is another set of lines. So these three are set of lines, but which we call them as a family of straight lines. Can we call this as a first as a family, second and third? So always remember, as I told, a family of straight lines means all the lines should satisfy a certain property. If you observe here in the first family of lines, in this set of lines, there won't be any particular property that we are observing here. So all lines are as they like. Can we call it as a family? No. In a family means all the persons, mother, father, son, daughters, grandfather, grandmother, they all stand by one word or whatever may be that. They satisfy certain rules. Then only we call it as a family. So this type of lines, they are not called as a family of straight lines. They are not called it as a family of straight lines. Now coming to these lines, you see here, all are passing through the same point. All are passing through the same point. That means we can call it as a concurrent lines. And this point is called point of concurrency. Okay, so this is called family of straight lines. So any family, so this is a family of straight lines. If a line, any line, if you take any line, if this belongs to this family, that line must passes through the point, this point. So this is called family of straight lines. Coming to the third set of lines, in this line, all lines are parallel to each other. All lines are parallel to each other. So these lines are also called as family of lines. This is also called it as a family of straight lines. Why? Because all are having the same common property. What is that common property? All are parallel to each other. Okay. Any line, you take any line. If this line wants to join in that family, so what is the property it should have? It should be parallel to any one of the line. Understand this? Any one of the line. If this line wants to join in this family, that line should passes through the point of concurrency. Okay, right. Now our question is, is there any equation, common equation, general equation representing the whole family of lines? That is the first one. The first thing is whole family of lines. Second one is, given if you want to find out the equation of each line in this family, then how to find out that? Okay. So if there any common one equation which represents the whole family, So let us see that concept. So welcome back to this concept. Family of, so you have understand what is that family of straight lines. So it is a set of lines which satisfies a given condition. Okay, now in a given rule, then only we call it as a family of straight lines. Now let us say take a one family of straight lines. So this is a family of straight lines. So this is a family of lines, all are passing through a fixed point. This is called concurrent lines. Okay. Now on the whole, how to find out the equation of the line is given by, if you know the equation of two lines, equation of any two lines, L1 and L2, any two lines, equations of any two lines, then the equation of the family of lines is given by L1 plus lambda L2 is equal to 0. L1 plus lambda L2 is equal to 0. Okay, now even then it is a parallel lines also. If there are a set of parallel lines are there, set of parallel lines are there. So these are all parallel lines. If you know the equations of any two lines, then the equation of the family of whole lines is L1 plus lambda L2 is equal to 0. Now the question arises, what is this lambdas are? So lambda is a parameter. Lambda is a parameter. So that means you can just like a variable. So you can take lambda is any value. For example, if you take lambda is equal to 1, then simplify that. You will get an equation of the line belongs to this family. If you take lambda is equal to 2, you will get an equation of the line which belongs to this family of lines. Okay. I will show you one practically, right. For example, let us take the equation of this first line is x plus y minus 3 is equal to 0. Equation of the first line is x plus y minus 3 is equal to 0. Let us take equation of another line is 2x plus y. So here point of intersection I am taking as a 1, 2 minus 4 is equal to 0. So if you observe, the point of intersection of these two lines is 1, 2. So let us substitute here 1 plus 2, 3, 3 minus 3, 0. 2 ones are 2, 2 plus 2, 4, 4 minus 1, 0. Okay, now what is the equation of family of lines? So this is equal to x plus y minus 3 plus lambda into 2x plus y minus 4 is equal to 0. So this equation contains infinite number of equations of the lines. That means here lambda is a parameter. You can take lambda any value. Lambda is equal to root 2, root 3, minus 1 by 2, minus 1 by 5, 5, 6, negative values, minus 3, minus 6, 5, 6, whatever may be the values you take. For suppose if I take lambda is equal to 1, what happens you see. If I take lambda is equal to 1, see here x plus 2x, 3x. Y plus y, 2y, minus 3 minus 4 minus 7 is equal to 0. Understand this? See here, so x plus 2x, 3x, y plus y, 2y, minus 3 minus 4 minus 7 is the equation of any family of the line. 2x plus y, x plus y minus 3 is equal to 0. So this is the plus 2x, 3x, y plus y, 2y, minus 3, minus 4, minus 7. Right. So here you observe here, if you observe this line, the equation of this line belongs to this family or not? Yes, surely. Why? Because see the point of intersection 1, 2, substitute here 1, 2, 3 into 1, 2, 2 2s are 4, 3 plus 4, 7, minus 7 is equal to 0. 7 minus 7 is equal to 0. Therefore, this is the line belongs to this family. Let us take one more example. That if you take lambda is equal to some 2, lambda is equal to 2. Check it. Here 2, 2 2s are 4x, 4x plus x, this is a 3x. 2 into y, 2y, 2y plus y, 3y. So this is a 2, no, minus 8, minus 8, minus 3, minus 11. Minus 11 is equal to 0. Understand this? So if you observe, substitute 1 and 2 here, 3 2s are 6, 1 and 2, 3 2, see here one more checking, I am taking lambda is equal to 2, no? So 2 2s are 4, 4x plus 1, 5x. This is a 5x, sorry. Now substitute here 1 comma 2 here, 1 2, 3 2s are 6, 6 plus 5 11, 11 minus 11 0. So from this what you observe? So if you take lambda is equal to 1, lambda is equal to 3, lambda is equal to minus 1, minus 2 also you can take, root 2, root 3 also you can take. You will get the equations of the family of lines which belongs to this family. Okay now. Let us check for the same case for parallel lines also. Let us take one of the line equation is 2x plus y minus, suppose I will take a 1 point, so this is a 2x plus y plus minus 2x plus y minus 3 is equal to 0. Let us take equation of another line is 2x plus y plus 8 is equal to 0. Is these two lines belongs to the family of parallel lines? Yes, 2x plus y, 2x plus y. So we know that equations of two parallel lines are differ by constant term only. Okay now. Now what is the equation of the family of lines? 2x plus y minus 3 plus lambda into 2x plus y plus 8 is equal to 0. Okay. Now lambda value goes on taking 1 1 1, you will get the equations of the lines which belongs to this family. Okay. So for example, if you take lambda is equal to 1, substitute here lambda is equal to 1. If you put lambda is equal to 1 here, 2x plus 2x, 4x, y plus y, 2y, minus 3 plus 8, minus 3 plus 8 plus 5 is equal to 0. So you divide with 2x plus y plus 5 by 2 is equal to 0. 2x plus y, again 2x plus y is the equation of the line belongs to this family. Okay now, right, very very easy concept. If you take lambda is equal to 2 also, if you take lambda is equal to 2, so 2 2s are 4x plus 2x, 6x, 6x, 2y plus y, 3y, right, minus 3 plus 16. That is equal to minus 3 plus 16 plus 13 is equal to 0. Okay now. See here the condition is parallel lines condition is what? A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. A1 by A2, 2 by 6, 1 by 3, 1 by 3, 1 by 3, 8 by 13 is not equal to C1 by C2. Therefore, from this we can say a family of lines is represented by the equation of the family of lines. So here the minimum of 2 lines equation should be required. Minimum 2 line equations. If you know the equations of 2 lines, then we can find out the family of, we can find out the equations of any line belong to that family. Okay now. So basing on that this family of lines, there are some important concepts are there. So let us see that. Okay. So dear students, in concurrent lines, that is a family of lines, there is a important some top points are there. So let me explain one by one briefly. So the first one is if there are 3 lines are there, if there are 3 lines are there, if they are concurrent. Concurrent means all are passing through the same point. All are passing through the same point. Then how to say that? How to prove that those 3 lines are concurrent? The first procedure is if it is L1, L2, L3, solve any 2 equations. Solve any 2 equations. You will get a point of intersection. Then substitute that point of intersection in the third line. You substitute the point of intersection in the third line. Therefore, if the third line also satisfied by that point, then the line also passing through the same point, no, then we can say that then the lines are concurrent. Okay. But other than that, a very easy method is there. So the method is determinant of the matrix A1, B1, C1, A2, B2, C2. So this is a A2, B2, C2 and A3, B3, C3 is equal to 0. Then we say that then also the 3 lines are concurrent. Okay. So the first part is over. Now coming to see here, if the lines are of this form, if these lines are of this form, that is a P1x, Q1y is equal to 1, P2x plus Q2y is equal to 1, P3x plus Q3y is equal to 1. They are concurrent if these three lines are concurrent. That is, they are all passing through the same point, concurrent. Then he is saying that P1 Q1, P2 Q2, P3 Q3 are collinear. Collinear means what? Lying on the same line. That means any one of these three lines. That is so this is a P1 Q1 and it is a P2 Q2 and it is P3 Q3. That means these 3 points lies on any one of the line. That is a P1 Q1, P2 Q2, P3 Q3 are collinear. They lies on the any one of the line. Okay, now right. The next one is if Ka plus Lb plus Mc is equal to 0. So here K, L, M, A, B, C like that. The point of concurrence of the lines represented by Ax plus By plus C is equal to 0 is. The point of concurrence of the lines represented by Ax plus By plus C is equal to 0. If that means this condition should be satisfied. So in place of X, K should be there, in place of Y, L should be there, in place of C, M should be there. Then the point of concurrence of the lines represented by Ax plus By plus C is equal to how much? K by M comma L by M. So that is the third next point. Next one is see here these lines are somewhat symmetric form. Symmetric form means here cyclic form, not symmetric form, cyclic form. Ax plus By plus C is equal to 0. Next line is Bx plus Cy plus A is equal to 0. That means in place of A, B came, in place of B, C came, in place of C, A came, cyclic. The next line is Cx plus Ay plus By is equal to 0. B plus C, C plus A plus B. So that is the three lines are cyclic. If these three lines are concurrent, then A plus B plus C is equal to 0 or A cube plus B cube plus C cube is equal to 3ABC. Okay. So how can you prove, sir? So you can take this condition, first condition, put here. So this is equal to ABC, BCA, CAB is equal to 0. ABC, BCA, CAB. Put it, you find out the determinant, you will get this A plus B plus C is equal to 0 or A cube plus B cube plus C cube is equal to 3ABC. Okay. So these are the basic concepts that are very, very useful while solving the problems from any competitive examinations. Okay, na? So let us, I hope that you understand this concept. So let us move to some more concepts. Welcome back to a very, very important concept, that is half planes. The name itself suggesting that half plane. What is meant by half plane? Let us take a two-dimensional coordinate system, x-axis and y-axis, and it is origin. X-axis, y-axis, origin. Let us take this is a plane. This is a plane equation. This is a plane. Okay. So if you draw a line in the plane, the total plane, the set of points which are belongs to this plane are divided into three disjoint sets. The three disjoint sets. What are the three disjoint sets? The lines, the point set of points which belongs to that one side. This is a one side. This is a one side of the line. Another one is a set of points which is belongs to its opposite side. Opposite side. What is another set of points which belongs to on the line? Which belongs to on the line. So that means when you draw a line in the plane, the total points are divided into three groups, three set of points, three disjoint sets. We can say that clearly three disjoint sets. So the lines, the point set of points which are on the one side, another set is opposite side, and another set is which lies on the line. So now we call them as the total plane is divided into two parts. We cannot say equal parts, but there are two parts. These two parts are called, so this is one half plane. So here it is one half plane. Understand? Half plane. That's when you draw a line, the total plane is divided into 2 points, two categories. So the one is called half plane, another part is also called the half plane. Okay, now our question is, so if you the equation of the line is, for example, ax plus by plus c is equal to 0. Let us call this as half plane h1 and this is called it as half plane h2. So that is h1, h2. So the line equation is given. Some L is equal to ax plus by plus c is equal to 0. Line equation given. For suppose if I have given on point 1 comma 2. For suppose if I have given 1 point 1 comma 2. Then how to say that this 1 comma 2 belongs to which half plane? This 1 comma 2 belongs to which half plane? And another one is what is the ratio divided by this line by these half planes. Okay, na? So let us see that concepts. Okay, welcome back. So here we have some very good notations. Let us see the notation point. So what is the notation is, for example, L is equal to ax plus by plus c is equal to 0. Ax plus by plus c is equal to 0. There are 2 points are there, x1 comma y1 and q x2 comma y2. There are 2 points are there. Okay. Now the notation L11 means, so here it is not equal to 0. So the notation L11 means x1 y1 substitute in this place, that is equal to ax1 plus by1 plus c. Understand this? The notation L22 means ax2 plus by2 plus c. So that is the notation L11 and L22. Sir, I will explain you taking one example. So for example, you take L is equal to some 2x minus 3y plus 5 is equal to 0. Let us take any 2 points, that is 1 comma 2 and minus 1 comma 3, any 2 points. Now what is the notation, what is the value of 1, 1, 1? So this is x1, y1, let us call it as, this is x2, y2. L111 means substitute this 1 and 2 in this x and y place. So that is equal to 2 minus, substitute here, minus 3 into 2 minus 6 plus 5. So this is a 2 plus 5, 7. 7 minus 6, 1. Therefore, the L11 value is 1. Let us substitute this. What is find out the value of L22? L22. Okay now. So what is the L22 means what? Substitute here. Don't put it is equal to 0. We have to find out the value. L11 value you have to find out. Now substitute this minus 1 in place of x. Substitute y 3 in place of y. Substitute here. So this is equal to minus 2. Substitute here 3. This is equal to minus 9 plus 5. Minus 2 minus 9 minus 11. Minus 11 plus 5 means minus 6. So your L11 value is 1, L22 value is minus 6. Okay now. So basing on this concept, so we have a very important important concept we have. Let us see that concept. After learning those concepts, so let us start one more concept. Let us learn one more concept, that is ratio in which a line divides a line segment. What is the meaning of that? For suppose there are 2 points are there. So one is x1 comma y1, another one is x2 comma y2. So this is a line segment. Okay now. So this is a line segment, a x1 comma y1, b x2 comma y2. There is a line which divides this line segment. So this is a line segment. So it is divided. It is not, may not be a perpendicular, may not be a perpendicular. So let us call it as this is sum L is equal to 0. The ratio is this. So this is a m is to n. So this is a ratio m is to n. So if you want to, so you know what is given? Point is given, B point is given, equation of the line is also given. Now you have to find out the ratio in which the line L is equal to 0 divides the line segment joining A and B. Okay now. So this ratio is given by the formula minus L11 is to L22. Minus L11 is to L22. So remember that means what? So this is equal to minus L11 by L22. If you want to find out the ratio m by n, this is minus L11 by L22. So it is minus is already in the formula. What is L11? Already we know that. So the point x1 comma y1, substitute in the left hand side of the equation, whatever may be the value you will get, that is L11. What is L22? So take the second point, substitute in the left hand side of the equation of the line, you will get L22 value. Understand? So, this is a minus L11 is to L22, it is a ratio. So, now here one question arises. The question is, so this is called internal division. So, this is called internal division. This is called internal division. Now, there is a chance of getting external division. External division. What is meant by external division? The external division means, see here in the internal division, this line L is equal to divides AB internally. That means this point of intersection lies on the line segment AB. Then we call it as an internal division. Then what about external division? Let us see that also. So, here there is a point A x1 comma y1, B x2 comma y2. Then the line L is equal to 0, it divides the extended. So, here, so this is L is equal to Ax plus By plus C is equal to 0. So, let us take this is the point of intersection. So, here it is a point of intersection, this point belongs to the line segment AB. But there the point P does not belongs to the line segment AB, but it lies on the extension of AB. So, it lies on the line containing AB. So, this is, if you imagine, it is a very big line. In that line the point is there, that means A, B, P are collinear. So, always remember note this point, the P may lie this A side also it may lie. Okay. Now, here the ratio means, so this is a M and it is N. Okay. Now, the ratio AP is to BP. Then this ratio is also the same formula, minus L1 is to L22. Same formula. Here also and there also the same formula, minus L11 is to L2, here also minus L11 is to L2. Now, here one very important two note points will come. What are those note points means? Always we know that if the internal division is there, so in the lower classes, in the 10th class we know that if the P divides AB internally, then the ratio is positive. That means this ratio is positive. Okay, now, when this ratio will become positive, already it is negative sign is there in the formula itself. When this is positive, so this will be positive when L11 and L22 have the opposite signs. If both have the same signs, for example, minus 2 by 3, 2, 3, forget about this minus, why? Because already it is minus, 2, 3, both have the same sign, That means, then it is always less than 0. If you make into positive, if you want to make into positive, minus 2 by 3, minus into minus plus, these two will have the opposite side. But otherwise, if it is 2, it should be minus 3. That means L11 and L22 have opposite sign. So, if L11 and L22, we know how to find out L11 value, L22 value. If this L11 and L22 have the opposite sign, then we say that the division is internal division. So, coming to here, so already we know that when the point P divides the line segment AB externally, the ratio will become negative. The ratio is negative. That means, this negative should be there, minus should be there. Then what should happen? L11 and L22 should have, L11 and L22 should have same sign. That means what? For example, minus 3 by 5. Here already it is minus is there. L11 value is 3, L22 value is 5. Therefore, minus 3 by 5. So, that means from this on the whole, if L11 and L22 are of opposite sign, if it is that is plus, if it is a minus, other is a minus, if it is a plus, then the division is internal division. If L11 and L22 have the same side, then the division is external division. So, I hope that you understand this concept. So, let us go for next concept. So, welcome to this very important theorems. These two are very important theorems. So, in the previous JEE mains examinations, there are certain bits which are given basing on these two theorems. So the first one is Menelaus theorem, second one is Ceva's theorem. Menelaus theorem and Ceva's theorem. So we don't need no need of any proof for this theorem, but let us take only the statement to solve the problem. So here the statement is take any triangle ABC. So ABC is any triangle. L is called the transversal. We call it as transversal. So that means it is intersecting two lines. A line which intersect or two or more lines at a distinct points is called a transversal. That is in the lower classes we have that. Let us say this transversal intersects AC at E, BC at D. Definitely, obviously, the same transversal should intersect the third side externally. So this transversal intersects two sides internally, but definitely there is obviously, so we cannot this cannot be intersect this AB internally. Definitely the transversal should intersect the third side externally. Let this divides at F externally. Okay, that means the transversal intersects all the three sides, two sides internally, one side is externally. Then the result is see here, systematically you observe here. So systematically observe here, the result is BD by DC into CE by EA into AF by FB is equal to -1. That means, see here, BD by DC is equal to CE by EA, CA by EA into, see here, AF by FB, AF by FB. That means F should come in between. AF by FB is given by -1, is given by -1. So once I am telling here, the line is a transversal, it intersects the two sides internally and the third side externally. Then the result, the output is BD by DC into CE by EA into AF by FB is given by the value -1. Okay, now coming to the Ceva's theorem, let us take O is any point in the plane. O is any point in the plane, but the point should not be on the sides of the triangle. On the sides of the triangle, you can take externally or internally. So to make you understand clearly, let us take the point in internal point. External also the same theorem applies. Now the line joining the vertex. So from here to here, the line joining the vertex. So O to A I joined. If we extend this line, this intersects the BC at D. That means opposite side of A is BC, it intersects at D. Okay. The line joining O and B, if you extend that side, it intersects AC at E. The line joining O and C intersects the opposite side of C, that is AB, at F. Understand this? That means take any point, join this point to all the vertices OA, OB, OC. Then you extend them. Definitely they will intersect the opposite sides of the vertices. No, let those points be D, E, F. Now the output is, final output is what the Ceva theorem says is the ratio, that is here, BD by DC into CE by EA into AF by FB is equal to 1. Here is equal to -1, there is equal to 1. Observe in both the theorems, left hand side parts are same. BD by DC, CE by EA, AF by FB. There also BD by DC, CE by EA, AF by FB. But in Menelaus theorem -1, but in Ceva's theorem +1. But here the concept is, here the transversal intersects all the three sides. The transversal intersects all the three sides, But here the concept is the line joining from a point to its opposite vertices divides the lines or divides the line segments. Okay, what are those line segments? Opposite side of A is BC, it divides D. The same concept, same ratio, but for Menelaus theorem -1, for Ceva's theorem +1 will give. Okay, now. So these two theorems are very important. In the sum of the problems, you can solve this using the Ceva's theorem and Menelaus theorem. I hope that you understand these two theorems, but proofs are not that much important. So proofs have somewhat lengthy, so no need of proofs. Okay, I hope that you understand today's all concept. So in the tomorrow's class, I will start the problems. Whatever may be the learning, what are the concepts we are learning, based on that we will do some problems on that. Okay, so until then, all the best.